Hey, and welcome to the channel where we make math make sense, and trust me, we'll be making a lot of sense today. We've got multiply, binomials, by polynomials, area model. Let's go ahead and get into a couple of examples. Alright, here we have this example where they ask us a rectangle has a height of b to the third power plus b squared and a width of b squared plus 7b plus 4. So we've got right here two term polynomial and a three-term polynomial, and two-term polynomial is called a binomial because there's two of them, two terms, two things being added, and a three-term polynomial is a trinomial. Now the only reason why that would be important for us to know is when we multiply, and we're multiplying here, and the word that gives it away, you're wondering like, Shalongo, where are you seeing multiply? If we're trying to find the area, then we know that we're multiplying the length times the width, because we know that that's the formula for area. So the reason why it's important to know binomial times trinomial is if you take two things and you multiply them by three things, then you should have five things afterwards. Whoops, that's if you add classic mix-up, six things afterwards. And you can see that in our boxes displayed. We got 1, 2, 3, 4, 5, 6. And so the concept here is if we find the area of the smaller boxes, then we can then add the area of the smaller boxes together for the area of the entire rectangle. So the first thing we're going to do is we're going to multiply each of these individual boxes, and when we multiply the coefficients, and then we count up how many of the variable are being multiplied. So 1 times 1 is 1. There are 3 b's being multiplied to 2 b's, so total how many b's are being multiplied? There's 5. In the middle box we've got 1 times 7 is 7. We've got 3 b's being multiplied to 1 b. Remember, there's exponent of 1 here. How many b's are being multiplied? There are 4 b's being multiplied. Last box on the right, top right, 1 times 4 is 4. And then there are 3 b's being multiplied right here, so we have b to the third power. Bottom left box, we've got 1 times 1 is 1. The variables, we've got 4 b's being multiplied. 2 up top and 2 coming from the side. 7 times 1 is 7. 2 b's times 1 b. How many b's are being multiplied? There are 3 b's being multiplied. The bottom right box, 4 times 1 is 4. And then there are 2 b's being multiplied from the left side, or the length. That's probably the width, right? Thank you, Ryan. Now that we've got the individual areas of these small boxes, we don't need to multiply anymore. We just need to add them together. So we add this to this, to this, to this, to this, and we've got our area. So I'm just gonna write the terms from greatest, well, probably just gonna identify if I can combine any like terms right here. So do I have any other x to the 5th powers? Nope. Okay, cool. I've got an x to the 4th power right here, and I've got an x to the 4th power right here. Sorry, b to the 4th power. Here we have b to the 3rd power. We got 2 of them that we'll be able to combine, and then we don't have any b squareds. So I can go ahead and actually add these together because they're like terms. I'm just gonna write that right here, combine like terms, and we got like terms right here. We're gonna combine like terms. Okay, so the standard form, we take the highest variable exponent, which is just b to the 5th. That's gonna get written first, plus, and we've got 1b to the 4th right here, and we've got 7b to the 4ths right here. So total we've got 8b to the 4ths, plus we've got 7b to the 3rds here, 4b to the 3rds here. So total we have 11b to the 3rds, and then we've got 4b squareds. And that is the area of this rectangle.